So today I'm going to present you a bit about what is the current state of research about climate change and grapevine, and I will frame some of our field experiments within that knowledge to see what we might expect and what kind of things, what kind of directions that climate change might be driving grape composition especially. So climate can be summarized very much by one thing, which is the growing degrees. And here's a map where we can see the growing degrees accumulation across California and how it fits into the different categories according to this Winkler publication down in the 40s, in which here we can see that how the California regions were classified, and that kind of gives you an idea of what kind of grape styles you can, grape cultivars and wine styles you can produce in each of those regions. But it's a rough estimator. However, temperature probably is one of the biggest driver of what kind of wine style we might decide to do within a site. However, I have to tell you that some of the data that we have about temperature, unfortunately, is highly biased. Some of the stations have been found out to be closer to air conditioners. Some others have been moved around. So therefore, there is a slightly overestimation of warming trends in some of the data that we have access to. Probably CIMIS is a good example of nice quality data. With the one that we have in Oakville, you can see that it's not close to any buildings. There's no building is reflecting back sunlight, and it probably is an example of a good data. But here we have two examples of things that have been a bit conditioned. So in this data, we see very striking warming trends. And that doesn't mean, the fact that they might be a bit biased, that doesn't mean that they have been increasing temperatures. Okay, so if we go to global reports and we can see the temperature evolution of the whole planet, we can talk about around 1C increase from pre-industrial times, and that means 1.8 Fahrenheit. However, here we see around 3.2 in the last 100 years, which might be a bit overestimated. However, the trend is still significant. It's something to bear in mind as we will see later on. An example of data, this is a very short trend, so therefore there is no such striking changes in temperature. But here we have a good example of what is the growing degree accumulation in the Napa Valley. This is the Oakville CIMIS station, which is on site where we work, and here we can see that it oscillates quite much. And in the last years, we had very warm years. Also, you can get the idea that roughly Napa has around 1,700 around 1,700 growing degree days measured for the growing season. If we compare that to Bordeaux and Rioja, which is slightly southern than Bordeaux, this trends look very similar to what it looks like in Napa. And those, as far as I remember, were taken from airports and locations that are supposed to have potential bias, but still, I must say that there are trends of increasing temperatures in both sites. If you look to more sophisticated reports where they corrected the data, this is raw data that I took from stations from airports. So, taking into account that there is an increase in global temperatures, there was a very famous publication in which what they did is took the distribution of some of the most common varieties, and what they did is, well, if we take into account the predictions for climate change, are we going to get out of the range of distribution of these varieties? And it turns out that many locations that we are growing, for instance, Cabernet, the temperature within the next 30 years might be over that range of temperature, and therefore their conclusion was that we will be out of that range and therefore might not be suitable. But the thing is that it's extremely hard to know what are the upper ranges of temperature for our grape variety. We have the lower ranges very clear. Okay, this is very easy to understand, because if you don't ripe the grapes to the point that you need to make the wine, I'm not saying about the alcoholic degree, but to make it something that you would say is representative of the wine that you want to make, you're not going to get that wine, and that is going to be a questionable business model. But if you have on the other side too much temperature, you can do many things. You can, of course, pick earlier, and therefore nothing related to sugars will be affected. Or there's other many aspects that play a role. For instance, there's a new trend in preferring wines coming from riper grapes, and that makes quite hard to establish when is going to be the point where we are going to see a no return, in which quality is definitely decreased. So going back to the topic of the lower limit of these varieties, here we can see a good example of why there is a very clear lower level of how much temperature we need to grow a specific wine style. Here we have I can see some people are having trouble with hearing my voice. So I show here a correlation between so here we have a correlation between the sugar levels and the vintage quality. This is, of course, a range of years that come from 88 to 97. And if you recall a bit from the graph, those were pretty cold years compared to the last 2 decades that we are in right now. And here we can see that sugar level correlates fairly well to the temperature, but because you can choose to pick earlier or later, that correlation gets a bit blurry between sugar levels and temperature. So that said, that there's a relationship between reaching a critical point of sugar, let's say ripening. I must say that it's not sugar what we are looking for. Okay, I'm talking about sugar because it's the easy thing to measure, but there's many other things related to reaching that sugar level, related to color, related to astringency, related to a flavor profile that we want to reach. And that sugar levels is how we can use as a proxy for those. And in this figure, we can see how there's a good correlation between the growing season mean temperature and then the vintage quality. And we can see here that some of the coolest years also have the lowest vintage quality. And we don't see that in the Napa data set because we don't have such a long record of vintage quality ratings. To what I could access, they all place in the warmer range of the plot. I could find more data. I didn't incorporate here, but for instance, there is 1 year, I think it's 1972, which has one of the lowest vintage ratings in Napa Valley, and it also matches with the lowest average temperature during the growing season in the record. That being said, we have also the higher temperature range, in which really it's hard to predict whether there's going to be a trend to decline in quality, and as many things playing role into this. However, this comes back to one of the big questions in vineyard management, which is whether to drop fruit or not. So if you take the perspective of somebody that it's risking not reaching the optimal ripening in a vineyard, that makes a question quite obvious, which is whether you are fine to lower the yield and, let's say, get a safer chance to reach the optimal maturity, or all the way around. You go for the higher yields, but at a certain point, if the year is not good, you might risk not reaching the optimal level of ripening. And I can advance you that leaving more fruit on the vine, we have seen a pretty steady correlation between leaving more fruit on the vine and having less soluble solids, which to a great extent, as you probably know, are sugars. But let's not forget one thing, it's that temperature does not magically produce sugars. I mean, sugars are a consequence of photosynthesis. Here we have a very generalized image in which I tried just to represent that, okay, through light we fixate carbon dioxide, and that's what ends up being the photoaccumulates, or in other words, that ends up being sugar in the grapes. And here we have a correlation between how much a plant can photosynthesize and how much Brix degrees accumulates per day. So in terms of climate change, if you go doing a quick search, what you will find is massive effects on phenology. And this is what you can see most immediately when you observe the trends in vineyards, because it's the data that is most available, which is that there is a very strong advance in the harvest time. I'm going to show you some more data now. These are 3 regions in France, and you can see that all of them in the last, these are very long-term records, and because these are not temperature, they don't have the same bias. You can see here that there is a trend to decrease, and in the very last decades, harvest is happening earlier than ever. But however, in one of my studies, what we did is decouple the effect of increasing temperatures on the 3 phenological events that are one after the other that lead to harvest. Okay, so the time to bud break, it was affected the most. It's affected around 4 days per degree in temperature change. Then we have the time to flowering that is affected from bud break to flowering that is affected 3 days, and then the time from flowering to harvest, which is affected only 2.5 days. So out of the whole phenological process, let's say that the one that we care about, which is the one that it's how fast the berry develops, is affected about 2 days, 2.5 days per degree change in temperature. So that observation of phenology come a lot of people to wondering whether the compaction of ripening, or whether this having the harvest earlier and earlier, it's problematic. And the truth is that in warmer regions, or in too warm years, we can see some things that are worrying of concerning the low acidity or the ripening too fast and ending up with some of flavors related to overripe grapes, but also the fact that people might want some of those effects on some certain varieties that masks a bit the potential concern of these factors. So if we considered that this was a problem, having the grapes ripening too fast, could we do something about this? Well, many people have come up with different things. One thing that I can show you right now is an example of how the ripening it works over time, and what happens when you compact or decompact. One example, for instance, you have here 2 rootstocks with very different vigor. And if you look at it, well, one ripens much faster than the other, but they both reach to the same point around, this is the beginning of October that the latest rootstock was reaching the same maturity. So there's a safety time that we can ensure that this is going to ripen and reach to the same point that we want. However, if we compare for the same date, for instance, anthocyanins, it looks like we have a much higher concentration of anthocyanins here in the fastest cultivar. However, I believe that those things have to be looked more in detail and compare fairly things that are in the same ripening point. And you can see here, for instance, that when you compare things that have been ripening faster or slower, there's not much difference. And actually, if you think that there might be a difference, it might be that the one that is the fastest, here the one on top, is the one that might have the highest anthocyanin content. We did not see any change in proanthocyanins. And here another example of doing the same exercise with titratable acidity. If we compare titratable acidity against time, both rootstocks are very similar, but if we plot them against bricks, we can see that the one that ripens the fastest has the highest acidity for the same bricks. And we have seen that on and on with bricks and pH. For instance, pH, if you want to keep a lower pH, faster ripening would always tend to be beneficial. That's related to the potassium absorption, but if I have time, I might go there a bit later. Another thing that we have to compact or decompact the ripening and the berry development, it's play around with the amount of surface or the amount of canopy that we have and the amount of fruit that we leave in the vine. So here we have a trial that we did over the last 2 years in Cabernet, and we have 3 combinations of crop load, which is 100% of the fruit, 66% and 33%. Taking into account that 100% is just removing the secondary crop. And the same thing with the leaf removal. We remove the laterals to make easier the calculations, and then we remove every other 1 every 3 leaves or 2 every 3 leaves. And we have the 9 combinations that have all of this. So sometimes I'm just going to plot the extreme treatments because that's enough to show that there's an effect. But some other times I will group them by fruit load or I will group them by canopy load. Okay. So this is how they look in the vineyard. This is the first year. The second year there was a bit more shoots. There were like at least 3 shoots per vine more. And we have here the 2 more extreme treatments. And then we applied a shade net, very light one, just to ensure that our effects were not due to overexposure. The treatment verification is here, and we can see that although we left the same amount of clusters in these treatments, the fact that we had only 1/3 of the canopy left us with a yield that it was nearly 2 kilos less, which is around 4 pounds less in this treatment that we left the same amount of clusters, and this was because the canopy was smaller. And that affected berry growth. We will see that later. The canopy area was according to the treatments and these 3 levels, and then the ratio between the canopy, the amount of canopy and the fruit, it was conditioned by the division of these 2 things. And of course, yes, we saw changes in phenology. I have here 3 phenological stages: bud break, flowering. This is veraison, and this is leaf fall. And you can see here that, of course, because the treatments were applied slightly after flowering, there is only effect on veraison. And also, quite funny is that leaf senescence, the rate that the leaves turn yellow, is very affected by this. If you leave more fruit, or if you have less compensated vines, the leaves will stay green for longer. Another thing that we saw, this phenology shift by these treatments is the ripening, of course. And this is the thing that was affected the most. Remember that we said before that it was about 2.5 days compaction per degree. You could assume that in other places might be more because especially in cold places it's more limited by temperature, the reaching maturity. But you can see here that a relationship between the different canopy levels and fruit levels can account for a huge impact on how fast those grapes ripen. And we can see here the correlation between the leaf to fruit mass ratio and the strong correlation against the solids at a certain date. We have changes in other parameters as well that you have to bear in mind. And one important one is that berry size. Berry size, some people might not think that this might play a huge role. And we tend to put all the effect on water deficit. We think that a water deficit will be the only thing that changes berry size, or at least to a great extent the only one. Well, here we have the difference in canopy size can affect berry size quite heavily. And we saw that at the end has an impact on the yield. Here we have also other examples, and this is one of them, that is the pH. When you have more fruit, the pH tends to be lower. These are the two treatments with higher fruit. And this will have to be checked, but it's most likely that the potassium that gets transported to the fruit, it has to spread through more fruit, and therefore the pH ends up being lower. So it's not surprising that mole production systems that are based on lower yields, if they ripe over a very long time, they may end up with a higher pH. Very slight changes in titratable acidity, by the way, but they are quite proportional to the Briggs differences. This I don't want to go very much in detail, but keep it the idea that the treatments that have the highest amount of fruit, this and this, have the highest anthocyanin content. There's a longer explanation for that, but let's say that for having more fruit, that doesn't mean that they are going to have less anthocyanins per se. Also bear in mind that these are, although they have the most fruit, and we didn't remove any cluster from this, these are also premium systems, in which is a BSP that I believe it was not much more than I think it was 6 tons an acre or something like that. I have it in another slide, I think. So facing climate change, the compaction of ripening, which is the same thing as saying this changes of the on phenology, especially compare the fruit set and the harvest. To me, might not be the big problem. Okay, there might be things related to compacting too much the ripening, but I think that temperature itself, it's enough to cause great changes in acidity and flavor, and those are the things that we might have to face more immediately, especially because those are really the only things that we can tackle, trying to modify berry temperature. Okay, and another thing that we have to keep in mind is related to acidity, is that this the compaction or doing this thing just you may leave more fruit because you want to, but as a strategy to go back to pre-climate change conditions, that might not be change everything back to normal. Okay, they might change many things. For instance, pH is one of the things that is beneficial, but there's many more things in detail that might not be changed for good with just leaving more fruit. So I wanted to also to present you explain you another concept that is a lot in the literature, which is the coupling of anthocyanins and sugars. Okay, so in some studies, what they have seen is that warm temperatures or let's say too high temperatures can delay the start of the accumulation of anthocyanins. This means that they start accumulating anthocyanins instead of with, let's say, 11 Brix, they start accumulating with 13 Brix, which in this study shows that those Brix difference, or that 1 Brix difference in the start of the accumulation of anthocyanins, is what makes grapes grown under higher temperatures have lower color. Okay, and this is the concept that explains that paper, and here's the real data, and we can see here that they did many experiments. Some of them they show this, which is the onset of anthocyanin accumulation. It gets delayed a bit in terms of the soil solids needed to start accumulating, and that ends up leading to a different concentration. But of course, they don't have that result in all the cases. In some cases, they have this result, which is just that they end up having a smaller concentration regardless of the starting point to accumulation of anthocyanins. I just thought it was nice to have the whole story of this thing of climate change, because that's another very trendy idea. So things, as I said before, to me the most interesting part of this is for the extension and the grower side is to try to affect berry temperature. And one of the things that you can do is, of course, we have seen all people using misters or sprinklers. They are not very frequent. And this is because during a heat wave, they can be helpful in terms of if you think that the decrease in temperature that you can create is critical for having an impact. But over time is not going to be helpful. Like, you cannot apply that on a daily basis. And for instance, things like temperature depend on that average temperature that are not so much affected by spike temperatures, and they are more depending on the average temperature. So another thing that we have, for instance, is the shade nets. We did a trial. I might have time to show some data. The major highlight is that we reduce about 8 Fahrenheit the temperature during the maximum peak of temperature. And you might think, well, 8 Fahrenheit might not be a huge deal, but in fact it is, because it's a matter of reaching a threshold temperature to find the berries collapse. And if you don't reach that temperature, you probably find, or let's say that the effects are dependent on having many more days of high temperatures. And finally, we did some tests with kaolin. Kaolin has a bit of a problem with sticking it to berries. Sticking to the bark of nut trees is extremely easy compared to berries. It's extremely easy to stick the kaolin to leaves. But to grapes, it can be quite challenging. There's numerous studies, even with grapes out there, and probably is a good idea to take a look at them. But from the practical side, we tried to test them, and we stopped at that point because it was some time to figure it out, and we have limited resources. So here we have the temperature of it's our maximum temperatures of 2017, and maybe some of you remember, some are not, but there was a heat spike quite significant around, it was this weekend at the end of, I think it was at the end of August. What is the? Labor Day. Yeah, exactly. Labor Day weekend. So we had temperatures of 44 degrees, which are, I think it's 112 Fahrenheit. And berry temperatures, you can imagine that those days were extremely high. So the trial that we did that year with the shade nets, this is the data that we have. And the important part of this is that the major gain is reducing the temperature while the grapes are close to ripening. When the grapes are green, the temperature gain is much slower. It's much smaller, sorry. This is probably because the cluster is less compact. Probably the grapes transpire a bit, and probably the color of the grapes helps also to reduce that temperature gain, even though the sun is probably have more strength during that time of the year because it's closer to June. June is the summer solstice, and here we have the time. This was almost close to harvest. I would say the first week of September, and there's two sides of the canopy. Okay, so this vineyard was oriented 135 degrees from the north. So this orientation in the map, if you see a map with the north pointing upwards, it's going to have this orientation. And you can see that canopy, the side of the canopy that received just a bit of sun in the morning, increased a bit. It was enough to be significant, but we don't have anything to worry at this temperature range. But however, the other side that reached, that had all the exposure during the 3 p.m. or so, which are the critical time of the year from 3 p.m. to 5 p.m., reach probably critical temperature, and we will see how this grapes look like. You can see here, this was a trial that you could walk by and have a much better impression of the results than looking into 100 graphs. Here you have the controls, and you can see that half of the clusters in some cases was totally sunburn, and on the other hand you have the shade nets that had this density. I get a lot of questions about the colors of the shade nets. We just work with blacks to don't add another factor of variability, okay? But I don't have anything against any other color for shade nets. I would say that if you choose white, probably you have to go through a thicker pattern. But that's all. So we have here the appearance of those grapes, and it was much better. And if you look at the quantitative data, we have 2 irrigation schedules, and those had very little effect. However, the shade nets, we only saw like maybe a couple clusters in the whole experiment, less than 5 clusters with any sort of damage. Of course, the north side that it was not exposed, the damage was 0%, and the side all the damage that we see here, it was coming from the south side, the southwest side that it was exposed on the evening. So we can see here that roughly around 25% of the clusters were falling into any of those categories, with at least part of that being damaged. You can decide, of course, whether that's something important or not. So another thing that I wanted to go in detail, because people, it's not easy to realize just by walking in the vineyards, and is that there's 2 ways that sunburn overexposure can be damaging to grapes. One thing is the exposure over time. This we can see it in vineyards that are not very well designed. Almost every year, you can see, especially in the first vine of the row, it's very easy to find a couple clusters like this in some vineyards, and this occurs over time. You don't need a heat wave for this to occur, and that ends up normally with half of the cluster in poor condition. But if you see the other half of the cluster, you will see that it's acceptable. And the other thing that we have seen only after that was Memorial Day? No. Memorial Day? Labor Day. Labor Day weekend, it was this, which is having grapes that were fully turned look like they were in variation. This light color, hours before, these grapes were fully turned. And the next day and the days after, those grapes dried out and just were not there anymore to be harvested. So portions of clusters die off, and this was because temperature was above 110 degrees, and they were also exposed. This didn't happen in any other cluster that was not exposed, and ended up in very temperatures of around 130 degrees. We did not collect the data, with all the representative, with all the replicates and everything. We just send a couple guys measure a couple clusters real quick, because it was really unbearable sometimes. And we reached this temperatures easily in exposed clusters around 3 p.m.
What variety was that?
This is Cabernet. So we have never seen any damage before variation, that's for sure. And we have never seen anything to be concerned before 2 weeks before variation. The thing is, would you, I guess that at that point you would put it whenever you have the time, the moment, the way we have them right now is they are fixed. So they We have 1 foot long nets that are fixed on the rows, and we never put them away. When we have the catch wires, we put them down, and it goes down with the catch wires. And it's not, I wouldn't say that it's zero problematic, but I would say that it's not an inconvenience. And after, this is the 3rd year that we have some nets in place, I have not seen any degradation of the material whatsoever.
How do you spray, build your spraying with these nets and kind of that timing?
Yeah. Let me show you a picture of the nets. So the nets are like this. These are 20% shading factor. It is a 30% by the commercials. That's what the commercial will say, a 30%. But because it's white, it only shades 20% of the. It only blocks 20% of the sun solar radiation. So with that, we never have seen any damage to be concerned about. We work with the 60% on the trials and 40% because at the end we need data to that it looks more clear the effect. But if I was putting the nets myself and thinking about the costs and the spraying, as you are saying, as many people are concerned about with the nets, I'll go for the 20%, and I think that will be fine. But still, I've seen vineyards with huge problems. I went to Montverdier with a friend a few months ago, and I saw cases where maybe I would think about a bit more than a 20%. But for us, that it was a quite problematic vineyard with 135 degree orientation. That net was enough. Let me, maybe at the end, I'm not very close. I'm not very far to finish. So this was another picture that I wanted to show, and this is something that should not be mistaken. Over-ripening. When you see over-ripening, it might look a bit like overexposure, but over-ripening happens all around the berry, like regardless of it has been the side that it has been exposed. It's going to show preferentially in the side that is going to be exposed because it has more evaporation. It has more water loss, that part of the grapes. But you're going to see the berries that are shrinking from all the sides. Okay, it's a funny pattern that I'm not sure if you can see in the picture. And there's another thing that looks a bit like that it can be water stress, which can dry out the clusters eventually. Again, this is something that you will see very equally distributed through the cluster. And finally, something that we see when the grapes are past bricks 25, 27, if you don't water to a certain amount, that can change much between conditions. You may see this, which are whole clusters that are just go dry, and we have very much in those vineyards that have not been irrigated for the last 2 weeks. So something really obvious, but I wanted to show what is the impact of overexposure in the composition. So here I'm going to show you the results, the chemical results of 4 classes of berries. Berries that are within the canopy. They have not seen the sun more than an hour a day probably, or even less. Berries that are well exposed, let's say in a side that it's kind of northeast or something like that, that it's and they have been exposed a decent amount of hours, but they don't show any signs of overexposure, and 2 levels of overexposure in which we have an idea from the picture that what kind of grapes this were. So in terms of anthocyanins, even the grapes of the within the canopy are fine. And they have optimal levels of anthocyanins. So that makes me think that there's many studies that show the relationship between light and anthocyanins, and that might be very true for many conditions that are not ours, which is the sunny California. And also tells me that these compounds are extremely sensitive to either high temperatures or overexposure. We have here the proanthocyanins, which are what we call the tannins, and these are a bit more resistant. We have here in the skin, they lost about a 50% whereas the anthocyanins are lost up to an 80%. But in the seeds, which is logic, because they are not as exposed, they are only lost about 30%. If you had a compound that is reactive to light, and this is unquestionable, you will have a response like this, which is grapes that are in the shade have a certain amount, and then you have a clear increase when you compare them to exposed grapes. Okay, and this is the case of the flavonols. These are not famous because they are not very well studied, and the relationship with grape wine quality is not very straightforward. But they're very funny guys. They react very much to light, and they are very useful for me to study how much light a grape has seen in its life. So that actually led to a system that we patented, and long story short, this is the relationship, the same figures that I showed you before, but in a more quantitative way instead of this grape categories. And we can see here that there's no need to open the canopies to have anthocyanins. There might be many other reasons why you need more open canopies, okay? But here we have grapes that come from, also I must say that it's from a premium vineyard, so it's not like we are comparing them from the grapes from the inside of a mechanically managed canopy or something like that. So some caution also has to be taken. But what is more importantly is that for these conditions, there's no relationship, or at least a positive one, between how much light you get and gaining anthocyanins. Whereas with the flavonols that are known to be very reactive to UV light, they increase a lot. Then they get degraded as well as anthocyanins. And we can see here that grapes that look overexposed, they lost some of these phenolates. So this led to one of our latest publications, which is relating basically a metabolic concept that, as the more compounds that you synthesize of this kind, the more likely they are to form this shape of this kind of the compound. But if you synthesize them slowly in the shade, you will have more proportion of these other compounds. Okay, these other compounds are also stimulated by water deficit. It doesn't matter so much which ones you have, but it is important because we have been using them as to quantify. So we have been plotting this to the modeling of the solar radiation. So what we did here is basically take an iPhone with a fisheye lens here, and then take a picture from the cluster perspective, taking into account where is the north, and then position that picture to model the trajectory of the sun, and then model how many hours of sun and how much sun strength it received, and then correct it with the CIMI station. So at the end, you get accumulated for the period of berry ripening how much solar radiation a grape had, and we correlated this to the chemical signal that I talked before. And we can see that there was a good correlation, and if you use that signal instead of measuring data for how much solar radiation a grape has seen, the correlation is much better. We see here in this figure how well it correlates to the solar radiation modeled, and it doesn't correlate as well as the signal. This is the chemical signal, and it correlates much better at the phase where it is increased, and then the phase that it's degraded. This is related to what Lucas showed before, which is, try to imagine, we have something that is in the berries that tells you how much light that grape has seen. So that has some usefulness, because otherwise people or researchers wouldn't put data loggers in the canopy to see how much light is penetrating throughout the growing season. And what we can see here is that it correlates very well to NDVI. It correlates also very, very well, much better than NDVI, to pruning mass. And it can be used to map how much light has the grapes has seen across the vineyard. And this is something that is already published, and it's open source. If you Google my name in Google Scholar, it will be the first entry for sure. And it's a paper relating basically that chemical signal, which you don't need to understand. Just need to understand that the more you have, the more it correlates linearly with the hours of exposure to the sun of a grape. And it's a powerful tool for us to assess how much light is penetrating through the canopy. I wanted to show you a picture of the kaolin trial. This is how it looked like, and you can see probably that there's no doubt that it stick very well to the leaves, but to the grapes that might be another question. Is this treatment that we applied to the grapes, and this treatment we only apply it to the canopy. Real quick, another thing that I wanted to show to acknowledge, and is that leaf removal treatments if you look for papers, there's many papers in which you would see that anthocyanins increase with leaf removal. That's something in many places, but we have done enough leaf removal trials at this point in which we have not seen a clear effect. So I still want to say that there's many reasons why you may want to do a leaf removal, but anthocyanins, which are the typical thing that people say, that are the things that get benefit, might not be the reason why you want to do it. You might find many other reasons, of course. So I think I'm going to skip this because it's the row orientation that have been explained before earlier today. And I think I explained it with the shade nets. But basically, what you need to know about row orientation is that most likely the ideal row orientation to keep temperature, berry temperature the lowest is 22 degrees north. This is because why 22 and not north to south? Some people may wonder. And it's because one thing is the moment that the temperature is, that the sun is the strongest, and the other thing is when temperature is the highest. Okay, so the highest temperature of the day is always delayed from solar noon. It's always after, let's say, at least 3 p.m. It's not 1:50 p.m., which is the solar noon. And by inclinating a bit the row orientation, what we are doing is that the period of maximum radiation, and the period of maximum temperature are the time of the day where the sun hits the canopy from above. So let's say that you have a time that you don't want the grapes to be exposed by any means. That will be the time. And aligning the row orientation with the sun orientation, that time of the day is the best way to get rid of that part of the day. So you will have grapes that will get hit early in the day and will reach a certain temperature, but by before they reach the critical temperature, it will switch to the other side, spend actually about an hour just hitting the canopy from above and therefore not hitting any berry whatsoever, and then switching to the other side and hitting the other side that it's only at ambient temperature. Okay, the grapes at that point will be at ambient temperature, and then they will increase as we can see here in this plot. These are not 22.5 degrees or 22 degrees, but they are pretty good row orientation, and we can see here that it changes the side around 2:30, and this is the point that this side starts to heat up, and it starts to decouple from ambient temperatures. So this system is preferable to this one because it doesn't reach critical temperatures as this reaches. So many places have row orientations that are north east to west and north to south. There's probably many good reasons why they do that, and especially this is common in places where BSP is not the main option, as BSP might be the most sensitive to this thing that I explained of changing side. Whereas if you have a canopy that is sprawls or a canopy that it's in a different shape, this concept is no longer the main thing that you may bear in mind. And in that case, the most critical thing that you may worry about is opening a space too much from above. When a canopy sprawls, if you don't have a cover from above, then it's when problems might start to appear. Whereas in a BSP is from the sides that you have to worry about. So thank you very much. I want to thank everybody that has been in our lab all these years, because they have been obviously been a great part of the data collection and elaboration. Thank you very much. Well, you're going in the direction that a plant that goes through heat stress may lose micronutrients. So what is the thought behind?
Optimal levels of calcium, for example, strength
Yeah.
of walls, less breakdown. Did you look at that at all?
No, I mean, there's many things that you can start looking into. The way we conceive the problem is being as a problem of reaching a critical temperature that can be damaging to any sort of tissue. Let's say that the temperature are high enough to don't think that you have to put such a elaborate mechanism to explain it. Let's say temperature of 130 degrees seem to be necessarily, killer. I don't. Yeah. So it's. I'm sure that that there's things that theories that can be elaborated around temperature, but in our case, we're going for very simplistic concepts. The thing with the flavonoids, it's mainly because they absorb that radiation and they are sensitive to temperature. They are degraded, but only temperature can explain that by itself. We did some tests, and when you put them in at different temperatures, you can see a very good response, like in matter of hours at 130 degrees. You can see the flavonoids going down at the same speeds. Let's say that anthocyanins go down the first, and then they go the proanthocyanins, which are the tannins, and they go in the similar pattern that they go in live grapes. So that's why we did not dig too much into that. Also because we are not that kind of lab. But thank you. Yeah.
A lot of your data was related to sort of solar exposure and
Anthocyanins?
And
Yeah.
that maybe here in California, sunny California, we don't need to manipulate our canopies to expose our fruit for anthocyanin production or optimization. But do you have any data that correlates to lithoxypyrazines and how those respond to leaving 100% leaf area?
Yeah, there's. We are starting to dig into that direction, but there's already a pretty good paper in which they use shade nets to play with with different levels of solar exposure, and they correlate that to the breakdown of methoxypyrazines. And what they find out is that pre-variation makes the difference. Like after variation, you probably don't care so much about how much exposure you get. That's why, as a precaution, it's fine to wait a bit for the shade nets to be placed on. But if I put myself aside of the data, which let's say have a intuition, put intuition into this, is like methoxypyrazines. I have not felt that much being a problem in many places. I assume that many people can come up with that being a problem. We work with Cabernet in this kind of warm places as a model, and then we never found that being an issue. But we are, as I said, we are digging into that direction because we are getting this kind of questions pretty often. So at least to say this or that with some true data, we are doing the job. But we will see. I mean, do you have the impression that wines have lower quality can have a lower quality because of green aromas?
No, I guess our interest is, our concern is a lot of us are moving towards protection.
Yeah.
So it's more canopy, protecting fruit from exposure, so you have less degradation.
Yeah.
And just keeping in the back of our minds,
Yeah.
we'd be setting ourselves up for a problem we haven't had in a long time.
Yeah.
And all of a sudden having more green flavors in these wines that are now in better condition, and the fruit's in better condition. And customers kind of bringing a four-letter word to a lot of consumers, even though in Cabernet in particular, pyrazines are part of the profile, but they've gotten such a low level.
Well, Cabernet is at 27 bricks.
Yeah, so it's one of those things we're just trying to keep mindful of, like,
Yeah.
solving one problem, are we maybe creating another one or not?
I mean, the advantage is that grape growers don't have the same problem as other fruit growers, which is having perfect fruit for the supermarket. So that's why I was hoping that even using tiny shade nets that only are in the angle of the maximum irradiation time of the day are enough to reduce that 25% of clusters with some important damage to maybe a 5%, which is something that you can handle, especially because you don't have to remove those grapes out of the cluster one by one or anything like that because they go on the bin. Yes?
How effective, it's pretty common to leave laterals on the side of the
Yeah.
I mean, how effective is that compared to shading? Because I work in a vineyard where one client has shading, I use laterals. It's really, how effective is
So,
lateral use compared to shading?
With laterals, I want to play a bit. Like I have some pending experiment to do because there's people assume that it's light exposure. There's a major reason why you will remove laterals, and it seems fair. But removing laterals does other things, and that's something I would like to dig a bit more. I have seen plants that we remove laterals with better maturation. And that's not something that we see with leaf removal. And I'm wondering a lot if that benefit is related to the exposure to the sun.
Yeah, I see lots of people who overexpose and then they put up shading.
Yeah.
It's like, well, why don't you just leave a little bit more?
Yeah. Well, I wouldn't do leaf removal, but lateral removal, I would like to.
Lateral removal, you get the problem.
Yeah.
You can leave some in targeted areas to protect the fruit, which is very common.
But also you have to bear in mind that it's a lot of canopy that it's like also condensing water some periods of the day. Like that's transpiring, and that's increasing the humidity, and the wind velocity is decreasing because of the laterals.
So removing all your laterals is pretty constrained.
Yeah. Well, I've seen only one side being the most, right? Well, is probably the most common, right? No? Removing laterals in one side? Yeah. Yeah. But
How protective is it compared to?
yeah, that's why I all the time saying, like, there's many reasons why you may still want to do many of the things, but having more anthocyanins, it's not one. So maybe if I'm happy to talk for hours then, okay? Thank you very much.
We're all long-winded. Thank you, Johann.